Okay, we're now going to look at something called a difference of two squares, which is the next method of factorising that we're going to learn. Okay, so we've looked at highest common factor, but now something called the difference of two squares. So let's just get going with this. Let's first of all cast our mind back to the FOIL method, and let's imagine that we were going to expand x plus 5 bracket x minus 5 out. Okay, so remember that FOIL is firsts, outsides, insides, lasts. So you get the firsts, you multiply them together. You get the outsides, you multiply them together. The insides, you multiply them together. And the last, you multiply them together. And then you add as you go. Okay, so first x times x is x squared. Outsides, x times minus 5, minus 5x. Insides, 5 times x is 5x. And finally, lasts 5 times minus 5 is minus 25. Okay, minus 5x plus 5x, so that goes to 0, that cancels out, and it just leaves me with x squared minus 25. Okay, what about g plus 4 bracket g minus 4? Okay, so first g times g is g squared, outside g times minus 4 is minus 4g, inside 4 times g is 4g, and then last 4 times minus 4 is minus 16. These two cancel out and it leaves me with minus 16. Okay. What about t plus 7 bracket t minus 7? Okay, first t times t is t squared, t times minus 7 is minus 7t, 7 times t is 7t, and then 7 times minus 7 is minus 49. These two cancel out in the middle and I get t squared minus 49. Now there's a pattern that's starting to emerge here that's going to allow us to do difference of two squares. And that pattern is as follows. Okay, so when I've got x plus 5, x minus 5, it turns out that the x is squared and that the 5 is squared, it's got 25. When it's g plus 4, g minus 4, a square the g you get g squared, a square the 4 to get 16. When it's t plus 7, t minus 7, a square the t you get t squared, and a square the 7 you get 49. In each case there's a minus in the middle. Now we would call that a difference of two squares. Okay, so a difference of two squares is when you've got a difference, a subtraction, and it's in between something squared and something else squared, like a squared minus b squared. Now factorising, remember, is putting things back into the brackets, so that's the opposite of expansion of brackets. Okay, so x squared minus 25. Okay, so we end up with a bracket with a plus and a bracket with a minus, and it ended up that that was x and that was 5. So the square root of x squared is x. The square root of 25 is 5. Okay. If it was t squared minus 49, bracket with a plus, bracket with a minus, square root of t squared is t, square root of 49 is 7. If it was g squared minus 16, that ends up being, well, a bracket with a plus, and a bracket with a minus. Square root of g squared is g, square root of 16 is 4. Okay, so let's try one where we don't have the answer. Let's take down example 1. Let's go for x squared minus 36. Okay, so we know that it's going to be a bracket with a plus and a bracket with a minus. The square root of x squared is x, and the square root of 36 is 6. Example 2. G squared minus 9. Okay. Bracket with a plus, bracket with a minus, square root of g squared is g, square root of 9 is 3. Okay, so we just did two very simple examples of difference two squares. Okay, so let's just underline what's happening again. Difference two squares. You've got the difference of something squared and something else squared. Now when you factorise that, you get two brackets, one with a plus, one with a minus. You then take the square root of a squared to be a, of a squared to be a, and then the square root of b squared to be b, and the square root of b squared to be b. And that's how you do difference of two squares. So let's try a third example. Okay, t squared minus 16. Okay, so we get a bracket with a plus and a bracket with a minus. The square root of t squared is t. The square root of 16 is 4. Okay, so let's just one more time check that worked. First outside's inside's last. First, t times t is t squared. Outside's t times minus 4 is minus 4t. Inside's 4 times t is 4t. And then last 4 times minus 4 is minus 16. They two cancel out, and it does leave me with t squared minus 16. So that method is definitely working for me. Okay, g squared minus 4. Okay, bracket with a plus, bracket with a minus. The square root of g squared is g. The square root of 4 is 2. Example 5. T squared minus 1. Okay, bracket with a plus, bracket with a minus. Square root of t squared is t. Square root of 1 is 1. Example 6. Let's this time go for 49 minus p squared. Okay, so a wee bit different this time. The number terms first, but that's fine. We just follow a routine. Bracket with a plus, bracket with a minus. The square root of 49 is 7. The square root of p squared is p. 7 plus p, 7 minus p. Now, incidentally, if you had written down 7 minus p, 7 plus p, that's absolutely fine. That's also the correct answer. And that's because when you multiply two things together, it doesn't matter which order in which they go, you'll still get the same answer. 4 times 3 is 12, and 3 times 4 is 12. Okay, example 7. Okay, example 7, let's go for 100 minus a squared. Okay, bracket with a plus, bracket with a minus. Square root of 100 is 10. The square root of a squared is a. Example 8. Okay, let's go for 4p squared minus 1. Okay, a wee bit different again. Right, so bracket with a plus, bracket with a minus. Okay, so the square root of 1, that's fine, that's 1. Since 1 times 1 is 1, what's the square root of 4p squared? That's quite easy as well. Square root of 4 is 2. Square root of p squared is p. So the square root of 4p squared is 2p. So final answer, 2p plus 1, 2p minus 1. Example 2. 9q squared minus 16. Okay, bracket with a plus, bracket with a minus. Square root of 16 is 4. Square root of 9 is 3. Square root of q squared is q. So the square root of 9q squared is 3q. Okay, example 10. 4 minus 25 y squared. Okay, bracket with a plus, bracket with a minus. Square root of 4 is 2. Square root of 25y squared, 5y. Okay, let's just introduce a slightly different dimension here. Example 11. Okay, 3x squared minus 27. Okay, it's worthwhile taking note at the side here, which is the first rule of factorising is to look for a highest common factor. So you always do that first. Okay, now for x squared minus 25, for example, you don't need to take that down, but there was no highest common factor, so it's just straight to difference of two squares. However, with this question up here, from 3 and 27, I can first of all take out a common factor there, which is 3. Remember, the factors are 3 are 1 and 3, the factors are 27 are 1, 3, 9 and 27. So it's 3 bracket x squared minus 9. Now we can now see that this bit is a difference of two squares, and just as normal, that would be a bracket with a plus, a bracket with a minus. Square root of x squared is x, square root of 9 is 3. So that would give me the same result there. However, I mustn't forget that there's also a 3 at the front. Final answer, 3 bracket x plus 3 bracket x minus 3. Okay, so these are kind of two-step questions then. So you first of all need to take your highest common factor and then look for the difference of two squares. Okay, so let's try another. 5x squared minus 45. Okay, so there's a common factor of 5. From 5 it's 1 and 5. From 45 it's 159. 45, the highest common factor is 5. 5 times what gives me 5x squared, that's x squared. Minus in the middle, 5 times what gives me 45, that's 9. Okay, so that's a difference of two squares. Bracket with a plus, bracket with a minus. Square root of x squared is x, square root of 9 is 3, but remember that there's a 5 at the front. Okay, example 13. Example 13, let's go for 4t squared minus 4. Okay, I can take out a common factor of 4, bracket t squared minus 1. That's the difference of two squares. Bracket with a plus, bracket with a minus, square root of t squared is t, square root of 1 is 1, but remember there's a 4 at the front. Okay, example 14. 4a squared minus 16c squared. Okay, so I can take out a common factor of 4. So that's 4 bracket a squared minus 4c squared. Since 4 times a squared is 4a squared and 4 times 4c squared is 16c squared. Okay, I can now do difference two squares, bracket plus bracket with a minus. Square root of a squared is a, square root of 4c squared is 2c, but remember there's a 4 at the front. Final answer, 4 bracket a plus 2c bracket a minus 2c. Okay, next example, let's go for 32 minus 2p squared. Okay, a wee bit different because the number comes first, but that's fine, just follow the rule. Okay, highest common factor, from 32 and 2 I can take 2, so that's 2 bracket 16 minus p squared. That's now a difference of two squares, bracket or plus, bracket or minus. Square root of 16 is 4 and square root of p squared is p, but remember that there is a 2 at the front. Example 17. 2 minus 18t squared. Okay, common factor of 2. 2 times what gives me 2, that's 1. 2 times what gives me 18t squared, that's 9t squared. That's now a difference of two squares. Bracket with a plus, bracket with a minus. Square root of 1 is 1. Square root of 9t squared is 3t. But remember there's a 2 at the front. Okay, example 19. 4a squared minus 9b squared. Okay, this example looks like it might be highest common factor and then difference two squares, but if you think about it, from 4 and 9, I can't take anything, so that's just straight difference of two squares. Bracket with a plus, bracket with a minus, square root of 4a squared, 2a, square root of 9b squared, 3b. Okay, let's try one final example, and let's go for 98 minus 2c squared. Okay, from 98 and 2, I can take 2. 2 times what gives me 98, be careful, that's 49. 2 times what gives me 2c squared, that's c squared. Okay, so that's now a difference of two squares. Actually, just come down here. Bracket with a plus, bracket with a minus. Square root of 49 is 7. Square root of c squared is c. But remember, there's a 2 at the front. Final answer.